Hi everyone. This video focuses on the hypothesis test for the population proportion. And I just realized something that I didn't say in the entire video, at least I don't think I did in all of these PowerPoints, which is again, what's the criteria for doing a test on a population proportion? Namely, that the data that you're working with is qualitative in nature or categorical. Okay, just a little review about the population proportion. We've already gone through this with the confidence interval for the proportion, but like the confidence interval, the hypothesis test for the population proportion, again, I did say, look at that, I did say qualitative data. All right, I can't emphasize that enough. This hypothesis test is based upon the sampling distribution of the proportion. If the following conditions are met, if you have a random sample of size n drawn from the population, and again, we've talked a little bit about that. Random samples are particularly difficult to obtain, so if you have a sample that's representative, this procedure is robust to that violation of the validity. 2, you have a sufficiently large sample, which is defined as one that satisfies the inequalities n times p is greater than 10, where p is the proportion of all successes in the population, and n times 1 minus p is greater than 10. If those two conditions are met, then the distribution of sample proportions, which is the sampling distribution, has a mean equal to the population proportion, has a standard error or standard deviation of p times 1 minus p over n and the square root of that, and is approximately normal. It's this normality that allows us to find the probability, the p-value, in the hypothesis test. Okay, so if, like all hypothesis tests, the tests about the population proportion basically assess competing claims. Is the population proportion equal to some value, which is the null hypothesis, versus the proportion is greater than that value or less than that value or not equal to that value? Again, in each case, the null hypothesis is that the population proportion equals something. As is generally the case, collect a sample, compute the sample proportion, calculate the z-value of that observed sample proportion using the test statistic, which is given here, then use the z-table or an appropriate applet or Statcrunch to find the p-value. And again, the p-value in this case would be the probability of observing a sample proportion of something or something more extreme if the true proportion is c. Okay, so I thought I'd come back to a couple examples. We've spoken about these, I know, in class somewhat, but first one is retention. We'll do this the old-fashioned way. We'll do it by hand. Universities are continually seeking to increase student retention. Suppose at a particular institution, the freshman to sophomore retention rate is 48%. It reminds me of what they often tell freshmen at the initial freshman orientation. Look to the left of you and look to the right of you, and at least one of you won't be here next year. Colleges are desperately trying to increase retention, as you know, as having students is essential to the conduct of the college. To increase its retention rate, the university adopts, say, new advising procedures. To determine if these procedures actually increase retention, the university randomly selects 268 first-year students that were advised using the new procedures, and of these 148 were retained. Do these data suggest that the new advising procedures were effective? And again, effective meaning that they increased the retention rate over what the traditional rate of 48%. Okay, so for this problem, and I think it's always a good idea to define your parameter, P represents the proportion of all first-year students that are retained after implementation of the procedures. The hypothesis is that the proportion of all first-year students that are retained, not only during this 1 year, but during all future years as well. So the proportion of all first-year students that are retained using the new advising procedures is 0.48, or 48%, versus that it's more effective that the proportion of all students that are retained is greater than 48%. The decision rule is, as is always is, reject H0 if the p-value is less than, and the level of significance is 0.05. The test statistic, which is how we'll calculate the p-value by hand, is given by that. Again, in all hypothesis tests, state the null and alternative hypothesis, the decision rule, and the test statistic. For the calculations, we know that 148 of the 268 students were retained. So the sample proportion is 148 divided by 268, or 55.22. That looks good. Bigger than 48%. The z-score for this sample proportion, using the test statistic, is a sample proportion minus what we think the population proportion is under the null hypothesis. And again, this also serves as the mean of the sampling distribution, divided by the standard error of the sample statistic. That equals 2.37. Again, that says that the observed sample proportion, the observed retention rate amongst the sample, is about 2.37 standard deviations greater than the 0.48. Okay, from the z table, the probability associated with z-score of 2.37 is 0.4931. But we don't want that. We want the probability of falling greater than 2.37, because we're looking for evidence that the population proportion has increased, is now greater than 0.48. So thus the p-value is 0.5 minus 0.4911, which is 0.0089. So we show the calculations. Finally, the conclusion: since the p-value is less than 0.05, we're going to reject H0 and conclude that the retention rate of all first-year students has increased after implementation of the new advising procedures. Note that I tried to stay away from a far-reaching conclusion saying that the retention rate has increased because of the implementation of the new procedures. We can't say exactly what the cause is. What we can say for a fact is that the rate, based upon our sample, the rate is significantly greater than the traditional rate of 0.48. Okay, is this procedure valid? Looking back at the statement of the problem, universities are continually seeking to increase student retention, so this is the original statement of the problem. One of the keys here I've highlighted in red: the university randomly selects 268 first-year students. So for the procedure to be valid, we have to have a random sample of first-year students was selected, which it was. N times P naught, and again, P naught is what we think the proportion is under the null hypothesis. So 268 times 0.48 is 128.64. That's bigger than 10. N times 1 minus P naught is 268 times 0.52 is 139.36, which is also bigger than 10. So the procedure is valid. In other words, the sampling distribution is normal, which allowed us to calculate the probability. That's what these validity conditions are really saying. Okay, a second example is based on a fact, something that is actually occurring in universities, and that is that the percentage of graduates that are women is slowly increasing, and the percentage of graduates that are men is slowly decreasing. In fact, and this was in 2011 were my latest statistics, the U.S. Census Bureau reported that 59.5% of all college graduates are now women. To determine whether this rate applies to NKU, a random sample of 64 recent graduates was selected, and the gender of each graduate was noted. These data are contained in the file, and I've got the file listed. Based upon these data, is there evidence that the proportion of graduates at NKU that are women, differs from the national graduation rate? Now, a key here, the evidence that the proportion differs. It doesn't say evidence that the proportion is greater or evidence that the proportion is less. It says that we're looking for evidence that it differs. So that would be a two-sided hypothesis, or not equal to. Again, for this problem, P represents the proportion of all NKU graduates that are women. And the hypotheses would be that the proportion of graduates that are women is same as the national average, 59.5% or 0.595, versus that proportion is not equal to 0.595. The decision rule and test statistic are still the same, since we still have a proportion for one sample. Okay, going to Statcrunch, I've loaded the data into Statcrunch. The first thing I might do, and there's a couple things that I will do here. The first thing is to get a count. This is the raw data. To get a count under statistics, if you go to table and construct a frequency table. Frequency table just essentially says, in this list of qualitative data, what's the frequency of males versus females. So the frequency data for the gender, graduation gender, or graduate gender, compute, and you get a table in this data of 64 individuals, 39 were women. It also computes the relative frequency. 39 out of 64, this would also be the sample proportion, the proportion of women of graduates in the sample that were women. Okay. The next thing I'm going to do, again, I will do this one not by hand, but with Statcrunch. So via Statcrunch, to conduct a proportion test, go to proportion statistics. This is one sample, since I've got one sample of graduates. Okay, and I have the raw data. Now, we want to pick the graduate gender. It's the only column we can pick. You have to tell it what a success is in this case. A success is, what are you looking for? Are you looking for the proportion of males, or are you looking for the proportion of females? If you notice, and see if I can get to it, I might have to go back out and take a look. The successes, we're looking for proportion of females. So we want to tell the computer, the program, to look for the female in this column. So going back to stat, proportion statistics, one sample with the data, graduate gender, the success is female. Again, what you pick as a success is should be relative to the problem. I have a hypothesis test for the population proportion. The null hypothesis is that p is 0.595 versus the alternative is not equal to 0.595, and I compute. And that would be my outcomes, okay, right there. Now, returning to the PowerPoint, I have actually copied the two tables from Statcrunch. Here's the frequency table. Here is the hypothesis test results. Notice the p-value is 0.8148. That would say that if the proportion of all graduates that are women at NKU is truly 0.595, our chance of finding a sample proportion of 0.6094, I rounded, okay, and that could be either 6094 or more, or essentially some equal value that is less. Because it's a two-sided hypothesis, we're looking for evidence that the proportion is actually significantly greater or significantly less than 0.595. Anyway, that proportion, or that p-value, is 0.8148. That essentially says that if the percentage of graduates at NKU is 59.5%, then we found a sample proportion that is very common. This is a highly expected result if the proportion of graduates at NKU that are women is truly 59.5%. Finally, coming to the conclusion, since the p-value, which is 0.8148, is greater than 0.05, do not reject H0. Thus, there's no evidence that the proportion of all NKU graduates that are women differs from the national proportion of 59.5%. The validity, we have a random sample of graduates. N times p0 is bigger than 10, and n times 1 minus p0 is also bigger than 10.